Hi, this is Sanjay Gangal from EDA Cafe. I'm here with Steve Sandler, CEO of Picotest. Hello, Steve.
Hi.
Well, thank you so much for joining us, Steve. Tell us about Picotest.
So Picotest is a company that I founded in 2010 for the specific purpose of providing measurement solutions for difficult measurements.
Okay, and so what are some of the products that you have?
At the beginning of our company, it seemed like most of what we were focused on was the interfaces between the boards that we were trying to measure and the instruments that we're using to measure on. And so, for example, if you wanted to do a Bode plot, you would need an injection transformer. And most companies, even Keysight, makes the analyzer, but they don't make the injection transformer. And so we focused on things like that. More recently, the problems have gotten a lot more difficult. We've started to make things like probes. We make very high accuracy, very high fidelity probes, and we've branched out to pocket-sized TDRs and preamplifiers, and now load steppers and things like that. So it's still really pretty much focused on interfaces between the device you want to measure and the instrument that you want to measure it with.
Okay, and you see a lot of activity in the data centers, artificial intelligence, HPC. So what is the impact of all this stuff?
That's a really great question. So, I mean, the explosive growth of AI, you can't miss it. It's front and center. Every place you turn around, you're seeing people building bigger clusters and higher powered AI, and of course that drives into higher power processors, and that's kind of NVIDIA's sweet spot right now. And I'm actually doing a panel discussion at DesignCon called "How It Is That the Explosion of AI Data Center and HPC is Impacting SIPA Engineers." So, the pressure all kind of flows downhill. So everybody wants to build bigger processors and more power, and that leads to many issues for us engineers in the trenches. One is, how do we test these things? Sockets have gotten really big. 15 millimeter socket can hold a 2000 amp chip. How do you test a 2000 amp chip? How do you create the 2000 amp power rail? Not only how do you test the VRM, but how do you test the actual distribution network? And one of the things that NVIDIA learned is that you have to test the thermal performance too. And so how do you test the thermal performance of a 2000 amp chip? And so all of this AI data center stuff puts pressure on us to make higher density VRMs to build higher fidelity test equipment. Of course, this is all now 48 volt intermediate bus instead of 12 volt intermediate bus. And that starts breaking test equipment. So how do you provide DC blocks that don't break the instruments, and so on and so forth? And it just keeps going and going. But right now, that's a big part of our focus. And 2000 amps is getting to be the norm in that world.
No, so tell us about your 2000 amp ultra high speed ASIC emulator.
So, in order to do a 2000 amp ASIC emulator, of course, you got to start by having 2000 amps. And that was a challenge because Picotest doesn't really make power supplies. Yes, I'm a power supply expert. We don't make power supplies. But we had to make 2000 amp power supplies just so we could test our high speed load. And actually have one here. Maybe you'll be able to see it. And that giant square in the center, that is the representation of the 100 millimeter by 100 millimeter socket. And now, if you want to do ASIC emulation, it's very different than something like the Intel VR test tool where they're testing the VRM. We want to do load excitations, but at package speeds, which is 100 to maybe 300 megahertz. And so what we had to develop, and we spent the last few years developing it, is a gallium nitride load cell, a very, very fast load cell that we could use to switch across the output power rail. And then we can create a very large array of these load cells if we can make them small enough, and that'll allow us to do 2000 amp stepping. And so what we're doing at DesignCon, we're actually showing 2000 amps doing pseudo-random data generation at 50 megasamples a second, which is about the fastest we can get our CPUs running at the moment. But we're doing real-time ASIC emulation where we can excite both the VRM and also the power distribution network.
And how do you cool this sucker?
There you go. You hit that right on the head. So,
Hmm,
gallium nitride is really great. It's ultra fast. Um, it's got a lot of benefits. It's also really small. And so trying to get the heat out of something that small is actually the difficult part. Creating the load cell wasn't so difficult, but we're actually running power dissipations of somewhere around 10 watts per square millimeter. That's a little
hmm,
bit nuts. And so this particular device is cooled by refrigerated liquid,
hmm,
and most of the magic is in the manifold that connects the gallium nitride to our manifold. But not only did it get into the gallium nitride, we also had to custom design resistors. We're not ready to talk about that quite yet, but it is coming really soon. We had to
hmm,
design custom 2-terminal and 3-terminal resistors, both for the power dissipation capability and also to be able to extend the bandwidth. Did I ever imagine having to design resistors?
hmm.
No, but I am thankful to the manufacturer that took it on with us, and it was a great ride. And ultimately, we did create the resistors we needed, and so we're ready to show off our load stepper.
No, no. And you have a panel discussion at DesignCon. What is the panel discussion about?
So the panel discussion is actually that very same topic, and it is how is all of this explosion in high power computing, whether it's AI data center or just HPC, how does that affect engineers in the trenches? And one, you just already mentioned it. What do these engineers know about electrothermal design? Not a whole heck of a lot.
Hmm,
Um, if you walked into my lab right now, it's probably more plumbing and refrigeration than anything else. I'm an electrical engineer. Um, so what happened here? And so it's putting a lot of pressure on engineers to do new things, but it's also putting pressure on all of us because, for example, the target impedance of a 2000 amp power rail is down around 30 microhms. How do you
hmm,
measure 30 microhms? That's really hard. We don't know. Nobody knows.
hmm,
But they come to me and they say, Steve, we got to measure 30 microhms. How do you do it? And we did. We got through the mathematics, and there's actually a 3-part article now on Signal Integrity Journal about how you measure 40 microhms, authored by Ben Dannon, and I co-authored it with him. But I derived the math, and we figured out what it took. And what it took was a magic common mode isolator, 100
hmm,
dB isolation requirement. How do you get to 100 dB? It's not so easy, but it was what was in the way. And I think
hmm.
that's the theme of what Picotest actually is. We're a company that takes on these difficult challenges. You need to make this measurement. We don't know what's in the way. You don't know what's in the way. We're going to find it. We're going to come up with a box that eliminates it. And so it goes. And every year we need a new box.
And you've been writing books on analog design, EM, and SPICE, and stuff like that for a while, right?
More than 30 years. I think my first
Well,
book was published in 1995. So I guess, yeah, 30 years.
and you got 4 books under your belt, or more than that?
I have 6 now,
Hmm,
but that counts 2 that were republications of the first book. I also have a book on uh, PI simulation with ADS. I have a measurement applications book, and I have a book called Power Integrity, which is different than most power integrity books. It focuses on making the measurements. How do you make the measurements? Because in my experience, that's where most engineers fail. They attempt to make the measurement, but they don't really understand the limitations. They end up with bad data, and then they design around the bad data. And so
hmm.
that's our entire focus here is how do we get good data?
Okay, and you must be having top-notch customers, since you are at the cutting edge of the latest and greatest chips, and that require the uh, most attention to details, right?
Yes, and it always surprises us here because we're such a tiny company, and yet our customer list is the who's who of the big gurus, and
Hmm,
and we take that really seriously. We understand what they have to do. We understand how important it is that they do it well, and we know how important it is that they get the right data, and that flows everywhere. For example, most engineers know how to make a power supply rejection ratio measurement. It's not that hard. You inject the signal into the power input and you measure what comes out. But now take a look at the latest transceivers, 3.2 terabit optical transceivers, and they need to measure the power supply rejection ratio. And it's a little different than the way we grew up. There's a
Hmm.
70 gigahertz instrument measuring data channels at the output side. And our job is to put in a modulation signal. And so, a company like maybe Molex would come to us, they make transceivers and they say, can you inject a signal at, 10 megahertz into our transceiver? Not so hard. We actually came up with a water cooled design that can do 50 amps and it can do it at 10 megahertz. And then another optical transceiver company comes in and says, well, we got 3.2 terabits. Can you get to a gigahertz with that?
Hmm.
Um, well, getting the interconnect to be short enough to get to a gigahertz is quite the challenge. But we figured out how to do it. You need to put the modulator into the tip of a probe so that there is no interconnect length. And then you pump an awful lot of cooling liquid through it to try to keep that gallium nitride that's in the tip cool. And yes, we can modulate hundreds of megahertz into a transceiver. But everybody's kind of doing this by the seat of their pants. Nobody really knows what to expect. Nobody really knows quite what's in the way. And so we're all just kind of plodding along, doing our things, moving
Hmm.
boulders and getting to the next one.
It's pretty amazing what you have been doing and what you are able to do in the. It is pretty mind-boggling. What is the best way for our audience to find out more about Picotest on the internet?
The first place that you should visit probably would just be our solutions page. We have a page that provides most of our solutions, and that'll also link to the external articles and things like that. I'm very active in the conference circuit, so DesignCon, EDICon, you'll find a lot of papers from that. But if you just go into Google and type Steve Sandler Power, you'll get a ton of stuff. So
Hmm.
that's probably a good way to start too.
Okay. And Steve, is it okay if I ask you a few personal questions?
Of course.
So, what do you do for fun outside work, or what is your personal passion?
Um, that's a really hard question because I love what I do. So what do I do for
Hmm.
fun? This is what I do for fun. I retired in 2000. I'm doing
Uh-huh.
this because it's fun. But when I'm not doing this, I really enjoy spending time with my family mostly. With my wife. I like to spend a lot of time with my wife.
Okay. Yeah, I mean, I can certainly see that, from a background and stuff like that, you must be finding this thing uh, fun. I mean, it's not just a job; it is something you like to do. And
I think so.
Yeah.
People ask me all the time, I complained I got to retire. And they said, but I mean, it's your company. You can retire anytime you want. So you keep complaining. Why didn't you retire?
Mhm.
And my wife always tells him it's because I don't really hate what I do. I love it.
Yeah, yeah, that's great. That's great. And Steve, can you also share something about yourself that most people at Picotest who work with you don't know about you?
Yeah, probably that I'm really big on pizza. Um,
Hmm.
I spent decades learning to make pizza. I mean, the authentic Naples style pizza. I have an Italian pizza oven here at home. Um, yeah, and I use all the traditional techniques to make certified Italian pizza. And for my 60th birthday, my wife actually rented out a restaurant here, which I think is the best pizza in the world. It has a pizziolo from Naples. And so she rented out the restaurant, including the pizziolo, so that I could make pizza with them for my 60th birthday. And so
Uh,
if I'm not doing this, I'm making pizza.
is the name of the restaurant Picciolo also?
The,
Or
the,
no?
the name of the restaurant is called Cibo, Cibo.
Huh. And where is it?
It's in downtown Phoenix.
Okay.
And I mean, I've had pizza everywhere in the world. I don't think there's any place that tops Cibo.
Okay. In the pizza oven that you got, what temperature do you cook your pizza at?
1100 degrees.
1100 degrees.
1100
Wow.
degrees. Yeah.
Thin crust, thick crust, medium.
It's Naples style, so it's pretty thin, pretty spongy, about 13 inches in diameter. We get most of the ingredients from Italy. The only thing we can't get from Italy is cheese. You can't import
Hmm.
cheese. I can go to Italy and bring it back, but I can't import cheese. So, but that's an incentive to go visit Italy every once in a while and come back with a bunch of cheese.
Okay, and how long does it take for the pizza to rise and be fully cooked?
It's about 60 seconds. In fact, there is a pizza law called VPN. And VPN protects all of the methods of making traditional Italian pizza, and it doesn't allow you to cook a pizza more than 90 seconds.
Wow,
Yeah, it's
wow.
pretty quick.
The-
The issue is that at those temperatures, the difference between nicely cooked and charcoal is a few seconds.
That's true. That's true. I'd love to try your pizza. Uh, call me next time you turn the oven on.
You bet. You bet. Anytime you're in Phoenix, we're making pizza. So that's something
Okay.
people don't know. And if you look really carefully in most of my presentations, there's a pizza.
Oh, okay. Okay. I'll be there at DesignCon.
Oh,
Bring some
great.
pizza
Great.
over.
I'll look
Yes.
forward to seeing you. We have a booth there this year.
Hmm.
It's the very first year we have a booth.
Hmm.
But you should see our papers. We have 3 papers and there's 2000 amp monster. We'll be at our booth.
Okay. A final question here, Steve. Cats or dogs?
Dogs, absolutely dogs.
Do you have any?
I do. We had 3, we lost 2, we gained 1, so we're back to 2. Um,
Okay. And what other dogs do you have?
they're both rescues, so they're both mixes, but they're both pit bull mixes. And
Okay.
we like taking pit bulls because nobody wants them, but they're actually very sweet dogs. They have a bad reputation, but they're very sweet dogs.
And how old are they?
One is going to be 14, so
Wow.
she's up there. The 2 we lost were older than her. She's the baby, and then the
Hmm.
new one is 3.
Okay. 3 is a good age. 3 is a fun
3 is a
age.
very good age, yes. But yeah, we do love dogs. My wife is very active with the rescues, and so that's her passion.
Okay. Well, thank you so much, Steve, for taking time to record this interview. Have a great day and stay safe.
Well, thanks. It was great to see you, and I look forward to seeing you at DesignCon.
Definitely. Yeah. There's Sanjay Gangal from EDA Cafe.